For the last decade, America was told that the self-driving war would be won by software. Not steel, not glass, not sensors. Software. Tesla talked about neural networks. Silicon Valley talked about artificial intelligence. Detroit talked about driver assistance mapped highways and safer automation. Rivian entered that same battlefield with the R2, a smaller, more affordable American EV designed to prove that autonomy could become a real business, not just a futuristic demo. But now a quieter threat is moving underneath that entire story. China may not be attacking the brain of the self-driving car. It may be attacking the eyes. Because LiDAR, the laser sensor that gives a vehicle a three-dimensional view of the road, is no longer just an expensive robo-taxi component. Chinese suppliers are pushing it toward mass production, lower cost, and wider adoption. And Reuters reported that Rivian is now considering building its own LiDAR sensors, possibly using Chinese technology, because the affordable options are increasingly coming from China. That turns the Rivian R2 into something bigger than an SUV. It becomes a test case. Can an American EV company build the next generation of autonomy without importing the economics of Chinese sensors? In America, the self-driving race was never sold as a sensor war. It was sold as a software revolution. Tesla made that argument louder than anyone. The company built its public identity around the idea that neural networks, massive driving data, and vision-based intelligence could eventually teach a car to understand the road, like a human driver. On Tesla's own AI page, the story is clear: fleets, neural networks, training compute, and real-world data become the engine of autonomy. Detroit followed a more cautious road. Ford built BlueCruise around hands-free driving in defined areas. GM pushed Super Cruise, then spent years chasing the bigger robo-taxi dream through Cruise, before pulling back from the most aggressive version of that bet. The language was different, but the center of gravity was similar: software mapping, validation, safety cases, and driver assist features slowly moving toward more automation. Then Rivian entered the middle lane. Rivian was not Detroit legacy. It was not Tesla either. It wanted the clean sheet identity of an EV startup, but with American outdoor credibility, its own software layer, over-the-air updates, and eventually a subscription-based autonomy business. Its newer autonomy platform already uses a dense sensor suite, cameras, radars, and powerful onboard compute, and Rivian describes its system as capable of more than 200 trillion operations per second. But here is the blind spot. Software does not see the road by itself. A neural network still needs inputs. A driving model still needs clean perception. A vehicle still needs enough information to know the difference between a shadow, a curb, a stalled truck, a cyclist, a construction cone, or a patch of dirty snow. And this is where China changed the battlefield. While America argued over whether autonomy should be camera-first, map-based, radar-assisted, or AI-defined Chinese suppliers, we're attacking a more industrial question. How do you make advanced perception hardware cheap enough to install at scale? That is why Rivian R2 matters. The R2 is not a six-figure robo-taxi prototype. It is supposed to be Rivian's bridge into a larger market. If Rivian wants autonomy to become a real product on that kind of vehicle, it cannot treat every sensor like exotic hardware. The old American question was, which software stack is smartest? The new question is harsher. Who can afford to give the car better eyes? To understand why this matters, do not think of LiDAR as just one more gadget mounted on a vehicle. Think of it as a different way for the car to understand reality. A camera sees the world as an image. It reads color, contrast, lane markings, brake lights, traffic signs, and human movement. Radar reads distance and speed, especially when rain, darkness, or fog makes vision less reliable. But LiDAR does something more geometric. It sends out laser pulses and measures how long they take to return, building a three-dimensional picture of the space around the vehicle. Camera is the eye, radar is the instinct, LiDAR is the measuring tape. That difference becomes important when the road stops looking clean. Imagine a Rivian R2 driving at night across Texas with a semi-truck changing lanes under harsh headlights, or crossing Michigan in winter where snow, salt, and dirty lane markings blur the road surface, or climbing a mountain road in Colorado where construction cones, cyclists, shadows, and rock debris create a messy environment that no polished demo video can fully control. LiDAR does not magically solve autonomy. It has limits. Weather can interfere. Integration is difficult. Software still has to interpret the data. But it gives the vehicle another independent layer of perception, a layer based less on guessing what an image means and more on measuring where objects are in space. For an autonomy system, that extra layer can be the difference between confidence and hesitation. And hesitation at highway speed is not just a software problem. It is a physics problem. But the sensor war is not won by proving that a technology works in a lab. It is won on the bill of materials. That is the brutal part most consumers never see. A vehicle can have the best sensor theory in the world, but if the hardware cost destroys the margin, it will never reach mass adoption. Autonomy is not just cameras, radar, LiDAR, and code. It is wiring, cooling, mounting points, cleaning systems, calibration, compute, redundancy, software validation, warranty risk, repair cost, insurance exposure. Every extra sensor has a shadow price. For a six-figure robotaxi prototype, that price may be acceptable. For a limited luxury vehicle, it may be absorbed into the sticker price. But the Rivian R2 is supposed to play a different game. It is supposed to move Rivian closer to the mainstream EV market, where thousands of dollars can decide whether a vehicle becomes a scale product or a niche product. That is why cheap LiDAR changes the discussion. If LiDAR stays expensive, it remains a premium feature. It becomes something automakers reserve for robotaxis, flagship SUVs, and laboratory-grade autonomy programs. But if LiDAR falls into the low hundreds of dollars, the equation changes. Suddenly, a sensor that once looked exotic becomes something an automaker can consider for a broader production vehicle. That is why Reuters' report on Rivian matters. The issue is not simply that Rivian is interested in LiDAR. The issue is that Rivian's CEO pointed to China as the place where affordable LiDAR options are becoming real. The sensor war is not about who can build the most impressive prototype. It is about who can make perception cheap enough to scale. This is where China's advantage becomes dangerous. Chinese LiDAR suppliers are not merely trying to win headlines at technology shows. They are trying to industrialize the sensor. That means factories yield rates automotive-grade reliability design, wins lower unit cost, and the slow transformation of LiDAR from exotic hardware into a mass production commodity. Hesai is the clearest example. The company announced at CES 2026 that it planned to expand annual production capacity to more than 4 million LiDAR units in 2026. Its 2025 results reported more than 1.62 million total LiDAR shipments, including about 1.38 million ADAS LiDAR units. Those numbers matter because they show LiDAR moving out of the experimental zone and into the industrial zone. Once a technology reaches that zone, the fight changes. Prices fall. Suppliers learn faster. Automakers get more choices. Software teams receive more real-world data. Manufacturing defects become easier to identify. And a technology that once looked optional can start to feel normal. This is the uncomfortable part for the American auto industry. If Chinese companies can make LiDAR cheap, compact, and available at scale, then US automakers face a difficult choice. They can reject Chinese sensor economics and risk building more expensive autonomy systems. They can buy into those economics and face political pressure. Or they can try to reproduce that cost curve domestically, which takes time, capital, talent, and industrial patience. Rivian is standing directly in that dilemma. It wants to own more of its autonomy stack. It is developing its own chips. It is trying to build a software-defined vehicle business that can generate revenue beyond the original sale. But the eyes of that system still have to be manufactured, priced, validated, and installed. That is why this is not just a LiDAR story. It is a supply chain story. It is a margin story. It is an industrial power story. Rivian is not looking at Chinese LiDAR because it wants dependency. It is looking because the cost curve is moving faster than America's sensor supply chain. To see why the Rivian R2 is the right battlefield, compare it with the 3 American autonomy philosophies around it. Tesla represents the camera-first argument. Tesla's full self-driving is still supervised, but its core message has always been, aggressive autonomy can be solved through vision neural networks, data, and compute. Tesla does not want the car to need expensive sensor layers if software can learn the road from cameras. That is a clean, powerful argument, and it is exactly why Tesla fans will fight this debate so hard. But Chinese LiDAR suppliers are making the opposite argument. They are not saying the car needs fewer sensors. They are saying more perception can become cheaper. That is a dangerous shift, because if a LiDAR module becomes affordable enough, the debate changes from, is LiDAR too expensive, to why doesn't your car have one? Tesla's philosophy puts pressure on Rivian from one side. China's sensor economics pressures it from the other. Ford represents the Detroit legacy path. BlueCruise is built around hands-free highway driving defined operating zones, driver monitoring, and gradual trust. That fits Detroit's risk culture. Ford must satisfy regulators, truck buyers, insurers, dealers, and families who do not want autonomy to feel experimental. But Ford also has a cost problem. If Chinese suppliers can make advanced perception hardware cheaper, then every American driver assist system starts facing a pricing comparison it did not ask for. Then there is GM. GM's retreat from Cruise is the warning sign. Robotaxi autonomy can consume billions of dollars before becoming a stable business. It is not enough to build an impressive demo. You need safety validation, public trust, fleet operations, insurance logic, regulatory patience, and hardware that does not destroy the business model. GM learned that autonomy is not just a software race, it is a capital furnace. That leaves Rivian in the middle. Rivian cannot simply copy Tesla's camera-first confidence. It cannot move as slowly as Detroit's traditional driver assist world, and it cannot afford to repeat GM's robotaxi burn rate. The R2 has to become something more practical, a mass-market American EV with a believable autonomy path and a hardware cost structure that does not collapse the margin. That is why the LiDAR module matters. In this video, Rivian R2 is the American test vehicle. Tesla is the philosophy challenge. Ford is the legacy benchmark. GM is the cautionary tale. And Chinese LiDAR is the cost weapon forcing every side to answer the same question. If better eyes become cheap, who gets left defending yesterday's sensor strategy? This is where the LiDAR story stops being a component story and becomes an industrial security story. A LiDAR module is not like a cup holder, a seat bracket, or a decorative trim piece. It sits inside the perception stack. It helps the vehicle understand space, distance, shape, movement, and danger. If the self-driving vehicle is a body, LiDAR is part of its visual nervous system. That means the real questions are not only technical. They are questions of control. Who designs the sensor? Who controls the firmware? Who owns the manufacturing process? Who validates the calibration? Who sees the failure data when the system misreads the road? And who carries the responsibility if a vehicle makes the wrong decision at highway speed? That is why Rivian's dilemma is so difficult. Reuters reported that Rivian is considering making its own LiDAR sensors, potentially with Chinese firms or Chinese technology, while exploring U.S. production as a way to reduce dependency and political exposure. The same report noted that low-cost LiDAR options are increasingly concentrated around Chinese suppliers such as Hesai and RoboSense. On paper, localization sounds like the escape route. Build the sensor in America. Protect the supply chain. Keep the jobs closer to home. Reduce exposure to tariffs, sanctions, and geopolitical shocks. But localization does not automatically solve the deeper problem. If the core know-how, supplier, tooling, optical design, or manufacturing recipe still comes from China, then Washington will ask a harder question. Is this American production or Chinese technology wearing an American factory address? Hesai shows why this issue is sensitive. The company has faced U.S. government scrutiny over alleged links to China's military, while Hesai has denied those claims and argued its LiDAR products are for civilian and commercial use. Reuters has reported on Hesai's legal fight over U.S. blacklisting, and AP has noted the company's rejection of allegations tying it to China's military. For Rivian, every option carries risk. If it builds LiDAR completely in-house, it spends more money and loses time. If it buys directly from Chinese suppliers, it may get the cost curve, but inherit political backlash. If it forms a joint venture, it may gain manufacturing scale, but raise questions over intellectual property data and control. If it avoids LiDAR altogether, it must convince buyers, regulators, and future robotaxi partners that camera and radar are enough for the next stage of autonomy. This matters because Rivian is not only selling vehicles, it is trying to sell a software future. Autonomy Plus is supposed to turn the vehicle into a recurring revenue platform, not just a one-time sale. But recurring revenue only works if the hardware underneath it is affordable, trusted, and scalable. Reuters reported that R2 hardware for Rivian's Autonomy Plus driver assistance system is built into all R2 vehicles, making this platform central to Rivian's next phase. That is the trap. American consumers want lower prices. American investors want software margins. American regulators want safety and security. American workers want domestic production. And Rivian needs all four at the same time. This is why Chinese LiDAR is dangerous. Not because every Chinese sensor is automatically unsafe. That would be too simple. The danger is that China may be building the cost structure that defines what affordable autonomy looks like. The problem is not that China can build LiDAR. The problem is that China may build the price of autonomy. Now put the sensor war on an American road. You are driving a Rivian R2 at night across Texas. The highway is long, flat, and fast. A semi-truck moves across the lane ahead. Headlights flare. Lane markings fade under old asphalt. A camera can see the image. Radar can read speed and distance. But LiDAR adds a geometric layer, a three-dimensional measurement of where objects actually sit in space. That extra layer does not make the car perfect, but it can make the car less blind. Now move north to Michigan in winter. The road is covered with slush. Salt stains the surface. Snow reflects light into the camera. The lane markings disappear under dirt and ice. This is where autonomy stops being a clean software demo and becomes an environmental test. The question is not whether one sensor is magical. The question is whether redundancy becomes necessary when the road itself starts lying to the vehicle. Then take the R2 into Colorado. A mountain road bends sharply. A cyclist appears near the shoulder. Construction cones narrow the lane. Rock debris sits near the edge of the road. A human driver slows down because instinct says the scene is unstable. A machine needs data to reach that same caution. This is where LiDAR becomes more than a spec sheet. It becomes trust. If Rivian wants the R2 to be more than another EV crossover, if it wants Autonomy Plus to become a real software business, then the vehicle must perform when American roads stop behaving like test tracks. Autonomy is not proven when the sky is clear. It is proven when the lane disappears, the weather turns, and the person inside the car starts asking whether the machine can really see. So the Rivian R2 is not just a smaller electric SUV. It is a test of whether American autonomy can survive the next cost war. Tesla chose the camera-first philosophy. Detroit chose cautious driver assistance. GM learned how brutally expensive autonomy can become when ambition outruns the business model. And Rivian is now trying to build the middle path, a software-defined American EV with enough intelligence to compete, enough hardware to be trusted, and enough cost discipline to scale. That is where Chinese LiDAR changes the story. It does not need to dominate every vehicle. It does not need to win every technical argument. It only needs to make advanced perception cheap enough that every automaker has to answer one uncomfortable question. Why are the better eyes not already on your car? For Rivian, this is the trap. The company wants independence, but autonomy needs hardware. It wants software margins, but sensors still have a price. It wants American credibility, but the fastest cost curve may be forming outside America. That is why this is not just a Rivian story. It is a warning to the entire US auto industry. The next self-driving war may not begin inside the neural network. It may begin inside a small LiDAR module built cheaply, scaled aggressively, and mounted quietly above the windshield. Rivian's real challenge is not whether LiDAR works. The challenge is whether an American EV company can build the next generation of autonomy without importing the economics of Chinese sensors.